Okay, all right. So some basic fundamental rules. We are meeting for 90 minutes, right? So I need you guys to make the best use of the time. So whatever like breaks, like washroom, this, that, finish it off before class. No snacking in class, please. Just you can have a glass of water. Videos on throughout the class so that I read a lot from your faces. So which is why I need the videos off. And no question is a bad question. Arjun, as feasible, please turn on the video bear.
Yes, so, just a minute, just a minute.
Okay, all right. And as I was saying, right, no question is a bad question. So different people might have covered different things in different places. So no, essentially, no, what shall I say, background is expected. Obviously, like basic school stuff, which you guys all know, and hopefully we'll be able to march on with that. Okay, all right. So stick with fundamentals. That's it, right? So we'll be going through a few formulas and all, but your basic process should be not being forced to use formulae. You should understand what's happening. I'll emphasize a lot on intuition. Okay, so you should understand what's happening, right? You cannot be clueless. Also, a good skill I would like you guys to develop is estimation, right? So if there are 3 or 4 choices, you can easily eliminate 1 or 2, which are like totally nonsensical, right? And the real competition will be between 2 or 3. Even if you don't know to do a problem fully, if you're able to reasonably estimate, you can eliminate at least a couple of answers. I'm not saying elimination should always be the just 1 second. Let me turn on the fan here. 1 second. I'm not saying elimination should be your first way of solving anything. But there will be situations where, especially some of the harder questions, you're able to proceed to a certain extent, but after that, you're not able to. So all these estimation skills will come in handy. Okay. All right. So let's get started then. Let me just share screen here. The class strength is supposed to be 10. So a few are missing, looks like. So I'm not checking who's on, but I recognize you guys. So let me just start sharing. Okay, are you guys able to see my screen? Well,
yes, sir. Yes.
Okay, great, cool. So broadly speaking, there are like 3 main topics, right? There's algebra. Okay, and in algebra, I'm trying to include a bit of arithmetic and bit of commercial math also in algebra. And then there is geometry. Okay, and then the third part is statistics, probability. Okay, so in this third branch, I would put statistics, probability, okay, and permutation combination, PNC, so permutation and combination. Okay, have you guys heard this word permutation combination? Arsh, what is permutation? Do you know?
No,
No?
sir.
Anjana, what about you?
So I think I know the meaning of combination, but I'm not sure about permutation.
Okay, fine. What is combination? Tell me, Anjana.
So combination is basically like 2 things in one. So like a pattern, I guess you could say, is a combination of things, or like grouping things together.
Yeah, sort of, right? Combination is like choosing, right? So let's say there are, you have a squad of 16 people, right? Representing the Indian team, let's say, right? So 16 people are there in the squad, but ultimately the playing 11 would be only 11, right? 11 in the team actually. So from 16, you'll have to choose 11, right? That act of choosing is called combination, right? So the way we are getting ahead of ourselves, but just so that you guys know. So this is represented as 16 choose 11. From the 16 people in the squad, how many different teams of 11 can I make? Okay, how many possibilities there are?
Okay.
That's called combination. Okay, any guesses for permutation? Anyone? Arjun, what about you?
Well, I think that in permutation, when you're choosing the order matters, but in combination it doesn't.
Exactly. So permutation is all about arranging. Okay. So permutation is all about arranging. So you don't focus on choosing at all. Right? Assume it's actually it is combination of choosing and arranging. Yes, right. So it's actually choosing plus arranging. But generally speaking, it's just the arrangement that you want to focus on. You choose and then you arrange. So permute essentially meaning different ways in which you can rearrange and count the number of ways you can arrange. For example, so let's say you have these 11 people who have selected in the team, right? Now, what should the batting order be? Let's say I'm talking about cricket here. Let's say there are 11 spots, right? Forget the conventional order where like standard 2 people come at the front and all that, right? In general, you can think about any 2 guys coming at the front, right? So any one of the 11 can come as the first spot and anyone else can be the runner among the 2 openers. And then someone comes after a wicket fall, someone comes after 2 wickets fall, and so on. And then there's only 1 person left at the final, right? So this 11 times, 10 times, 9 times till 1 is
7
your
factorial.
11 factorial, right? Have you guys all seen this symbol called factorial? Okay, Prashast, have you seen this symbol, Prashast?
Like, so this means factorial as in like 11 into 10 into 9 into 8 into etc. till 1.
Correct. Yeah. Any factorial means you keep going in descending order from that number all the way till 1 and multiply. That's called factorial.
Factorial, I have a question, sir.
Yes, go ahead.
It was specifically for multiplication, right?
Specifically for multiplication, yes. Yeah. It's a product. Yeah, it's a product from that number downwards all the way till 1. And it's only for integers. You cannot talk about 3.7 factorial, right? I mean, you can. I mean, there are ways later that you will learn, but for the most part, you can forget about it. You cannot have a non-integer with a factorial, right? Because how will you end up at 1? If you keep going down, you'll cross over 1. You'll never reach 1 exactly. Right?
It has to end in 1.
It has to end in 1, and therefore you have to start with an integer and go down till 1.
Okay, sir.
Okay, cool. So what I was going to say is the third branch is, I'll just erase all of this. Okay, so permutation, combination, probability and statistics. So that is one collection together that we'll do. Okay, so the plan is we'll be spending a few classes on each of these topics first. Over the first few classes, we'll spend a good amount of time learning the basics of each of these. And then we'll do topical questions for each of them afterwards, right? So that's the plan. Okay, so let's start with any preference, guys. So anything that you, Akshar, among these, what's your favorite topic?
Sir, any is fine, sir.
Any is fine, but in general, what's your preference? What topic do you like most?
Maybe probability.
Probability. Okay, all right.
So, sir, I Prashast would like to go with algebra.
You prefer algebra. Okay, all right. Okay, fine. Any other takers?
Good.
Sorry?
I agree with him. Algebra sounds good.
Algebra. Okay, all right. So fine, but I do have a preference. So I thought I'll get started with geometry, because somehow I feel that algebra, like a lot of you people are pretty good. Geometry is where there's a bit of a weak spot, right? So unfortunately, textbooks and conventional math that we are studying these days, too much emphasis is not given on geometry. So let's start with geometry. Of course, algebra is not running away. We'll definitely spend a good amount of time doing algebra. Okay, so let's start with geometry today. Okay, so this is our block today. Okay, so geometry, we are primarily going to study triangles property, related property, and then we'll go to quadrilaterals after that. Okay, and then in general, properties of polygons. Okay, and then we'll touch on circles just a bit. Okay, whatever is needed, bare minimum for circles. Okay, and along the way, a few coordinate geometry also will come, right? I'll explain to you what that means when we get to that. Okay, so let's start with triangles. Just a basic recap of triangles, right? So there are essentially 2 different classifications of triangles, right? On one hand, you can say whether it's acute or right or obtuse. Okay, that's one level of classification. And
But
then
so you could say like scalene, equilateral, isosceles. You can like side lengthwise.
correct, exactly. So there are two ways in which you can classify, which is equilateral, isosceles, and then scalene. So these are two sort of different dimensions of classification. This looking down is one way, looking this way is another way. Okay, so some of these combinations are possible, some of them are not possible. Okay, so Arena, can an equilateral triangle be acute?
Yes,
Is this, yeah, in fact, it is always acute, right? 60,
Yes,
60, 60. Yeah. Purav, can an equilateral triangle be right?
No, sir.
No, it cannot be, as we just said. So equilateral triangle is 60, 60, 60. Therefore, it's obtuse is also not possible. Isosceles triangle being acute. Akshar, can you give me an example of isosceles triangle being acute?
So it could be like 45, 45, 90.
But if, okay, but in that case, it doesn't become an acute angle triangle, right? It becomes a right angle triangle.
But it's also acute because two of the angles are acute also.
If two angles are acute, is that enough for the triangle to be acute?
No, sir, sorry, my bad.
Yeah, all three angles have to be acute, right? So can you
Yes.
try once more? An example of an isosceles acute angle triangle.
Like 75, 20, 85.
Okay, you are making me do a lot of calculation. Why can't we give a simple example?
Yeah.
Oh, no, I'm just kidding. Yes. What did he say? 75, 25, and 80, right?
No,
Perfect.
sir, yeah, that also.
75, 25, and 80, or yeah. In general, when you have a given example, just stick with the simple one, right? So 60, 70, balance 50, right? The three angles are 60, 70, 50. That's all. Oh, sorry. What did I say? Isosceles acute, right? I'm sorry. I was not paying attention.
I think still just be 60, 60, 60, right?
If it's 60, 60, 60, then it becomes equilateral. When we're talking isosceles here, you want two angles to be equal. What is the example you said, Akshar? I'm sorry.
75, 75, 30 is
75, 75, 30. Yes, 75, 75, 30 is possible, right? So I forgot that we are talking about isosceles here. So these two sides are equal. Okay, therefore it's isosceles. So technically 60, 60, 60 is also isosceles. Isosceles requires two angles to be equal. It doesn't say the third angle should not be equal. Okay, so technically even 60, 60, 60, you can say it's an isosceles, right? It passes the criteria for isosceles. Of course, it just so happens the third angle is also equal, and therefore it's the name equilateral. Okay, so by the way, we call here equilateral. Okay, equilateral meaning side. Lateral refers to side. So in general, lateral refers to side. All right, there's equiangular as well. Okay.
Yes, sir. And equiangular triangles are not unique triangles, right?
So yes, so equilateral triangles are also not unique that way. So equiangular means all the angles are equal. Okay, so in general, these terms apply not merely for triangles; they apply for bigger sided polygons as well. So polygon is okay. So just since we are defining what a so what is a polygon? A polygon is something that's constructed of straight lines. So this is a polygon, for example.
and has more and has three or more sides.
Sorry, say that again, Arjun.
Sir, constructed of straight lines and has three or more sides.
Three or more sides, correct. And the smallest polygon is, of course, a triangle. So a most general polygon would look something like this, right? The sides are all straight, but they don't have to be equal. The angles don't have to be equal. And intentionally, I've drawn an angle which is more than 180. Okay. Akrit, there's a name for an angle which is more than 180. Do you know what it's called?
Reflex.
Reflex angle, yes, right? So between 90 and 180, an angle is called obtuse, and more than 180, it's called a reflex angle. Okay, so I've intentionally drawn a polygon which is a reflex angle as well. Okay, so equilateral and equiangular apply for polygons too, not merely for triangles. But only in a case of triangle, both mean the same. An equilateral triangle is effectively same as an equiangular triangle. But even in the case of quadrilateral, that's not true. Okay, so Purav, what is an equilateral quadrilateral?
Square.
Okay. Can I request whoever I'm asking to answer? For now, it's okay. Okay, square is not wrong, but so does it have to be a square then, Arsh? Or rather, let me ask you this question. Does an equilateral quadrilateral have to be a square?
Yes, sir.
Purav, do you agree with him or do you disagree with him? I cannot hear you. You're unmuted, but I cannot hear you.
Equilateral, quadrilateral, it can also be a figure like a rhombus.
Excellent. Yes. A rhombus is where the four sides are equal, right? So,
Yeah.
Arsh, does it make sense? So it does not have to be a square. A square is still not wrong. A square is very much an equilateral quadrilateral, but it need not be a square, right? It's enough for it to be a rhombus. Okay. So, Arina, what's an equiangular quadrilateral?
I'm sorry, I don't know.
Okay. I'm sure you know this. Think about it. What does equiangular mean?
When all the angles are like the same.
Equal. And you understand what a quadrilateral is. It has four sides. Okay. So what would an equiangular quadrilateral be? Guys, you don't have to lift up your hands. I'll ask. I'll come around and ask. Don't worry. Yeah.
A rectangle.
Rectangle. Yes. Right. A rectangle would be an equiangular quadrilateral. Okay. Precious, what would be something which is both equiangular and equilateral
So
quadrilateral?
a square because it has to fall in the middle.
Correct. It has to satisfy both equilateral and equiangular. Therefore, it has to be square. Okay. All right. So back to triangle properties. So we have isosceles, and then in an isosceles right triangle, Anjana, what would be an example for an isosceles right triangle be?
90 and then 45, 45.
Correct. Is that the only possibility in terms of angles for an isosceles right triangle?
It could also be like 40, 50.
If it's
90,
40, if it's 40, 50, then is it isosceles?
Oh, no, it won't be isosceles. Then. I think this is the only one.
Exactly. Because you want it to be right, therefore one angle is fixed to be 90, and you want the other two angles to be equal, which means they have to be 45, 45. So there's no other choice. There's only one. There's a unique. So I'll just put one, right? There's a unique isosceles right angle triangle, just like there's a unique acute angle triangle, acute equilateral triangle, right? There's only 60, 60, 60. There's no other choice. Okay. All right. So let's complete this. Akshar, isosceles right, isosceles obtuse angle triangle.
This is not possible, sir.
It's not possible. Okay.
Yes.
Purav, do you agree or disagree with him? He's saying this is not possible. Do you agree or disagree? Again, I cannot hear you. Something wrong with your this thing.
So it is possible.
Okay, then give a counter example.
So if suppose we have one angle, let's say 150 degrees.
Yeah.
You can still have 15 degrees and 15 degrees, it'll still be isosceles.
Exactly, right? You can make this angle big, like this example that you gave, it's 150 degrees, and the balance 30 gets equally split as 15 and 50. Okay, perfect. Okay, and then does it make sense, Akshar? Why it's possible?
Yes, sir.
Okay, cool. And scalene, of course, all three are possible, right? All of us can give examples for acute. So I can give a 60, 70, 90, 80. Let's say this is 80. This is, I'm not drawing it to scale or something. This is 70. Let's say this is the balance, right? 30, right? 80, 70, and 30. Scalene right angle triangle, also possible. Something like this, right? You can have you can give in terms of sides, you can give, right? This, let's say this is a 3 and this is a 4. 3, 4, 5 is a very popular
Pythagorean triplet. Yeah.
Pythagorean triplet. 3, 4, 5 is a popular Pythagorean triplet, right? Where the sides are all different. Arina, do you know approximately what this angle would be for a 3, 4, 5 triangle? Very approximately. I cannot hear you. Mute. Unmute. I don't expect you guys to know this. I mean, if you know, that's great. If you don't know, it's not a big deal. Arjun, what about you?
So I think it's 36
Yes, so
to 90.
obtuse now. Obtuse could be like 150, 150 and 30.
Yeah. So you were correct. You were jumping ahead on this one. No, yes, I'll take that answer for obtuse scalene. I heard that. But yes, Arjun, I heard your answer. The well answered, right? So I was asking in a 3, 4, 5 triangle, the sides are 3 units, 4 units, and 5 units. What's the measure of the angle opposite to 3? So that's approximately 37 degrees, right? It's just a useful information to know. And likewise, this angle therefore will be 53 degrees. In a 3, 4, 5 right angle triangle, the side opposite to, the angle opposite to the smallest side will be 37 degrees. Okay. And now, Arsh, you were right in saying obtuse angle. You gave an example. What was that again? 120 something you said. Let's say this is 120. I'll just make up an example. Doesn't matter. This is 40. And then let's say this is the balance 20. Okay. So there are many of these. Okay. So the important ones obviously will be the equilateral triangles, the isosceles triangles, and the right angle triangles, right? And especially in right angle, you'll have the isosceles right angle triangle is extremely important. So just let's spend a couple of minutes on the isosceles right angle. So let's say I have an isosceles right angle like this. Okay, so there's a particular ratio of the side lengths. So let's say this is small a, then this is also small a, right? Lengthwise. Okay, so let's label this triangle as PQR. Okay. So if this is small a and this is small a, by Pythagoras theorem, this becomes square root of a square plus a square. So it becomes square root of 2a square, right? Which you can simplify as root 2 into a. So the ratio of the sides in a 45, 45, 90 is 1:1 is to root 2. Yeah, Precious, you had a doubt?
So I just had a question.
Yes.
So like we know by the Pythagorean theorem that like a perpendicular squared plus base squared is equal to hypotenuse squared.
Correct.
Right. So then that would mean that in this case, a squared plus a squared is equal to the other side, let's call it b squared.
Correct.
So then how did we get to square root of 2a squared? How did we get there?
Yeah, so you called this one as b, right? Okay, so basically you rightly said b square equal to a square plus a square, which is 2a square. So, and therefore b is the square root of that, right? So square root of 2a square.
Okay, got it.
Isn't it? So which is square root of 2 times a. Okay, all right. So the ratio therefore is 1:1 is to root 2. Okay, a small digression on square root. Let's see. Arjun, what is square? Just a basic question only, but just to be clear on the understanding, what is square root of 36? Okay, I have two choices here. Okay, which of these will you pick?
Sir, the second B.
B. Does someone agree or disagree with him? So he has picked this.
So I agree. So B is the correct answer.
Okay. So a couple of people say B. I just want to listen everyone's opinion. Arsh, do you agree or disagree?
I agree.
You agree. Okay. All of you are unfortunately wrong. When I say square root of 36, it's always the positive square root. When you put the square root symbol, the definition of the square root symbol is always the positive root. So if someone asks x square equal to 36, what are the values for x? Then for this problem, you will say x could be plus or minus 6. Or rather, you would say it's plus or minus square root of 36. But square root of 36 is always by definition the positive one, which is 6, right? So the definition of square root is always the positive square root.
Sir, can I ask why?
That's just the definition, right? So people long ago have made a definition. So it's too late to change it now. Yes.
Yeah. So like before the quadratics and yeah.
Okay. So x square equal to 36. So if on the other hand, if I have a separate problem, y equal to root of 36, then that has only one answer. Y equal to 6 is the only answer. So x square equal to 36 has two answers because you can see it's a quadratic, right? Quadratic meaning it has a power of 2 that we are trying to solve, right? Whereas y equal to root 36 is not a quadratic, it's a linear. Linear means the highest power of the variable that we are trying to solve is 1. So this is a linear, and therefore you expect only one answer for it, namely plus 6. And this is a quadratic. Okay, Arjun, does it make sense?
Yes. sir.
Okay, so it's a very common mistake people make. I'm glad some of you did as well, so that only if you make mistakes, you'll all understand. Okay, all right. So the other popular right angle triangle is 30, 60, 90. Okay, let's erase this. Okay, so let's draw 30, 60, 90. Extend this label. Okay, so the labeling of triangles is important. So let's say this is A, B, and C. Now, in the previous problem, I deviated slightly just to illustrate the concept of A square plus A square equal to square root of 2A square, that one. But the labeling, conventionally, what we should do is the side opposite to the angle should be written in the same small letter. So this should be small a because it's opposite to capital A. Okay, and the side opposite to the capital C should be small c. And then the hypotenuse in this case is B. Okay, so in this case, let's say I'm focusing on a 30, 60, 90. So this angle is 30, this angle is 60, and this angle is 90. Okay, would you know what the ratio of C is to A? I'm writing in ascending order. No? So one other thing, in any triangle, the sides will be in the same ascending order as the angles opposite to them. So in this case, 30 is the smallest angle, 30 degrees is the smallest angle. Therefore, the smallest side will be small c. 60 degrees is the next one. Therefore, the middle side would be A. And the one opposite to 90 degree, namely the hypotenuse, will obviously be the longest side. So who was I asking? I forgot. I was asking Purav, I think. Yeah, for Purav. Do you know what the ratio? And guys, can I request that whoever I ask, please interject, please respond. And who I know you're all into. I assure you that all of you will get your chances. Okay, so C is to A is to B. Purav, do you know what that ratio would be? Precious, I want you on your seat, beta. Okay, you're nearby only, right? Okay, cool. If someone is going away for a short break or restroom, let's inform and go, please. Okay, C is to A is to B. If you know it, you know it. It's not a big deal. If you don't know, it's
3 is to 2 is to 1.
3 is to, you mean 1 is to 2 is to 3. You mean because C is the smallest one.
Yes.
1 is to 2 is to 3.
Yes.
Okay. But that's the ratio of the angles, 30 degree, 60 degree, 90 degree. That's so capital C is to capital A is to capital B is 30 is to 60 is to 90, which is the ratio of 1 is to 2 is to 3. Now you're saying the ratio of the sides is also that same ratio. That's what Purav is saying. Arsh, do you agree or disagree with him?
I disagree.
Okay, what do you think it should be?
Or
you don't know what it is, but you disagree with him.
Yeah, I disagree with them.
Okay, there must be some basis for disagreeing, right?
Yes, sir.
Is there any reason why you would disagree?
Because like it can't always be equal, because supposing if you take a bigger ratio angle, we still get the same angles, and hence you always don't get the ratios 1 is to 2 is to 3, so sometimes it might differ.
Yeah, so intuitively you're seeing that it's not right and correct.
Yes.
You are, Arsh, you are right in that, Purav, it is not 1 is to 2 is to 3. But is there any other reason you guys can think of why 1 is to 2 is to 3 is wrong? Forget about 30, 60, 90. In no triangle.
So in the above examples, you can just see like both those sides, the angles are like 45, 45, 90. But the ratio is 1 is to 1 is to root 2, not 1 is to 1 is to 2.
Correct. So that's fine. But see, just because it is not happening there, it doesn't mean it does not have to happen here, right? Right? Akrit, I understand your logic. Just because it's not happening, so it's like saying one guy cut the signal and the police didn't give him a ticket, whatever, right? So that guy crossed the signal, you didn't give him a ticket. I crossed, now you're giving. It's like that. The argument is like that, right? Just because it's not happening here doesn't mean it cannot happen at all, right? Prashant, you were saying something?
Yes, so it's first of all the main thing that stands out here. It cannot be correct because number one, it's not a Pythagorean triplet. You look at it, it is not a Pythagorean triplet. 1 square plus 2 square is not equal to 3 square.
Correct. Fundamentally, that is where the break is, right? 1 square plus 2 square is not 3 square. So that's enough to say it's Okay, but then I posed another question, right? I said, forget about this 30, 60, 90. In no triangle, so let's say I draw another triangle, which is, I'm not saying it's a right angle triangle, therefore you cannot apply the Pythagoras theorem. Let's say there is a triangle like this. In this triangle, suppose I mark this ratio of these sides, or again, don't go by scale, right? If in this triangle, if 1 is to 2 is to 3, even then you can tell I'm wrong.
Here, yes, because like the two other sides which are not the base, their sum has to be greater than the base itself. Otherwise, it is not a triangle.
Exactly, right? The sum of the two sides, any two sides, sum of any two sides should exceed the third side. So obviously it makes sense to talk about the sum of the smallest two ones should exceed the third one, should strictly exceed the third one. Okay, and Arjun, why is that? Why does it have to be that sides in a triangle should sum up to a quantity which is more than the third side? Do you know about this property, Arjun?
Yes, there is a triangular inequality.
Okay, why is that? I mean, meaning, like, just intuitively you can tell me. Why is
Sir,
it that
I don't know the reason of it, but it's just that the sum of the two sides should be more than the third side.
Okay, Anjana, do you know this property, Anjana, that two sides should add up to more than the third side?
I don't think so, sir.
Okay, all right. Then I'll pass it on to someone. Akrit, knew about this?
Yeah, sir, because like if it's 1 and 2, then it will just form a straight line if you just like
Exactly.
draw it.
Exactly. Right. So suppose I place the 3 at the bottom here. Let's say this is 3 units. Let's say I have 3 sticks, one of measurement 1, one of measurement 2, another one of measurement 3. Okay. So let's say I place the 1 here and 2 here. Okay. I keep, right now it's not a triangle. I try to collapse it. When it just collapses to the base, then this length becomes 1 and this length becomes 2. Right? It forms a 0, 0, 180 degree wala triangle. As in, it's just a line segment. It's not a triangle at all. Right? You can just visually see that for it to form a triangle, after lifting it up, it should still form a triangle, which means when you collapse, there must be some overlap. Correct? When you collapse, there must be some overlap. Only then after you lift up, it will form a triangle. Yes, Anjana, go ahead. Yeah, you're on mute.
It's also an important point to remember. If it collapses, then it can't be a triangle, obviously.
Exactly.
So
if it collapses even just perfectly, it's not a triangle because it becomes sort of like a 0, 0, 0 degree, 0 degree, 180 degree wala triangle, which is not a triangle at all. Right?
so if it was like, say, 2, 2, and 3, then it would have worked.
Correct. Exactly.
So just reach that proper amount for it to work, then only will it.
Correct. It does not even have to be 2, 2, and 3. You're just talking integers here. But yes, I can have the sides as 2.1, let's say 3.2, and then 5.29. Let's say these two adding up to 5.3, right? This triangle is possible. It will be a very, very flat triangle, but you can see that 2.1 and 3.2 still add up to a quantity which is more than 5.29. Therefore, there'll be some bit of overlap, and therefore you can lift it up slightly and form a triangle. Okay, right. So long story. Okay, we'll learn a lot of things, right? As we digress, we'll learn a lot of things. That's the beauty of math, right? There's always something, right? Now back to the original question: what is the ratio of C is to A is to B? Akrit, do you know the ratio of 3 sides in a?
1 is to root 3 is to 2.
Exactly. This ratio is 1 is to root 3 is to 2. Okay. Did anyone else know this before? Arena, did you knew this? Did you know this earlier?
But sir, how come we are at root 3? Where did this come from?
We'll derive it. Don't worry. We'll derive it, Precious. Don't worry. Thoda shanti irukku. Okay, we'll definitely. Okay, good. I like your enthusiasm. Okay, but yes, definitely we'll prove it. Okay, cool. So let's do it this way. I'll reflect this triangle below. So this is 30, 60, 90. So I'm going to reflect it below like this. Okay, so right now I'm pretending I don't know it's 1 is to root 3 is to 2. I'm going to derive it's 1 is to root 3 is to 2. So by reflecting, let me just write this up a little bit here, up here. So this is my A. Okay, so if I reflect it, then this length is also small c, correct? This length is also small c. Okay, so this is small b, and this big triangle right now, if you look, this is 60 degree. Now, by reflection, this is 30, and therefore this entire angle is also 60, and this is also 60, which means, excuse me, this big triangle is a equilateral triangle, which means the sides are all equal, which means this B has to match times small c, right? Because this entire length is 2c, right? C plus c, and therefore small b must be 2c. Does it make sense? Therefore, if we compare C is to B, that's 1:2. We have arrived at one of them. Does it make sense? Akshar, are you with me?
Sir, I understood.
Understood, right? Now we can apply Pythagoras theorem and find out what A is. So A is nothing but square root of B square, which is 2C whole square, minus C square. So which is nothing but square root of 4C square minus C square, which is root 3 times C. So that's how the root 3 comes.
Wait. So can you just explain that once more?
Okay, so you understood till the part where small b equal to 2c?
Yes, small b is equal to 2c, correct?
Understood, right? Because the big triangle is equilateral triangle. And then I'm just applying Pythagoras theorem. So how do I arrive at A using B and using C? B square minus C square is your A square.
Wait. I don't get it.
Okay, what does Pythagoras theorem tell us here? So in this
So
triangle, just
Pythagoras theorem is perpendicular squared plus
Yeah.
base squared is equal to hypotenuse squared.
exactly,
Yeah.
that's exactly what I'm doing here. Base is
Huh.
small a, this other one is small c, and this hypotenuse is small b. Therefore, A
Okay.
square plus C square equal to B square, but B is nothing but 2C. So I've replaced it.
So it will be 2c squared, correct?
I've taken the C square to this side and taken a root. That's it.
Oh, okay. And then, so then how did we get to square root of 3 squared?
You
3c
tell me,
squared.
what is 2C whole square? Isn't it 4C square?
2c whole square is, yes, 4c squared.
4C square minus C square is?
Oh, 3c squared. Okay, so we just simplified it then.
Exactly.
Sir,
Okay.
I have a question.
Yes, Sanjana.
How did we arrive at A is equal to root 2C the whole square minus C square? I'm confused still.
That's exactly what I was just telling right now. So I apply Pythagoras theorem on the triangle ABC. In the triangle ABC, right? So we know C square plus A square equal to B square, correct?
Sir, I understood the Pythagoras part. I
Yeah.
didn't understand.
Yes.
Why
Okay,
it's-
so you're almost there, right? So A square equal to B square minus C square, and B is nothing but 2C.
Oh wait, I understood now because A square, so you can make it A root. Okay, I understand.
Yeah, so B is nothing but 2C, and therefore it's square root of 3. Okay, so bottom line, the ratio of the 30, 60, 90, the three sides is 1 is to root 3 is to 2. And this is a very, 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 very important property. You know, many Olympiads, they give questions which are based on the simple ratio, 1 is to root 3 is to 2. So always try to dig out triangles which are either isosceles right angle, like the 45, 45, 90, which is 1 is to root 2 that we just saw. Also the 30, 60, 90 triangles where the ratio is 1 is to root 3 is to 2 that we just saw. Both of these are very, very popular. Okay, you guys with me? Okay.
Yes, sir.
Okay, right. Now let's spend a bit more time on Pythagorean triplets. So the common ones you guys know are 3, 4, 5. Arena, can you tell me some other triplet, Arena, other than 3, 4, 5? You're on mute.
I'm sorry, can you repeat the question?
Okay. Do you agree that 3, 4, 5 is a Pythagorean triplet? So I have to write Pythagorean triplet. Right? Do you understand what that means, Arena? The three side lengths which will form a right angle triangle. So 3 square plus 4 square happens to be 5 square. Therefore, it's a Pythagorean triplet. Do you know any other common triplets like that? Is my question. Have you come across other triplets?
I remember this, but like it's not coming to my brain.
Now it's coming to you right now. Okay, Purav, what about you? Unmute, guys. Okay, Purav is really struggling with unmuting. Yes.
6, 8, and 10.
Good. Okay, I was just going to say that. Okay, 6, 8, and 10 is just doubling all of these, right? So that way I can tell 30, 40, 50, right? In fact, my mistake, I didn't qualify, right? After simplifying, it's all of these collapses to 3:4:5, agreed? So I want something which is outside of this 3, 4, 5 family.
So can
Right? I'll give chance. Purav, do you know of any? Else I'll pass it on to Akshar. Yeah, go ahead, Akshar.
So if I'm not wrong, so 12, 5, 13.
Yeah, try in ascending order. So 5, 12, and 13. Okay.
Yes, sir.
Precious, anything else you know?
No, sir, not sure.
No. Okay. Krit,
So I don't remember.
you don't remember. Okay. Anyone? Arjun?
Yes, just a second.
Okay, he's working it out.
So
Okay.
so 9 to okay.
Was it something like 14, 15, and 17?
14, 15, and 17.
Okay. 8, 5, 17.
So it can be
So-
9. It can be 3, 9, 10.
So it was 8, 15, 17.
8, 15, 17. Yeah. Okay. Yeah, 8, 15, 17 is a triplet, not 14, 15, 17. But I'll come to that. 8, 15, 17. Okay.
3,
Anything
9,
else?
10. 3, 9, 10.
3, 9, 10. 3, 9, 10.
Yes, sir.
Oh,
81 plus 9 equals to
90
sorry.
is not 100.
Yes, sir. My
Yeah?
bad.
No worries.
Calculation.
5, 12, 15.
5, 12, 13 is already called out. Arjun, you started something with 9 something something. What was that?
So that was 9, 12, 15. I realized it's just
9, 12, 15 is a 3, 4, 5 family extension, right?
Yes.
So yes, so he said 9, 12, and 15, but then that collapses. If you divide throughout by 3, the ratio is just 3:4:5. So I won't count that one.
7, 23, 25. No, 7, 24, 25.
Very good. Okay. Very
Yeah.
good. Ajay. So 7, 24, and 25. You're calling it out from memory, or you remember this? I mean, both are same. Sorry. You're calling out from memory, correct? Seven-
I also did a little bit of multiplication.
Fine. No, nothing wrong with memory. Okay. I don't know why this remembering something is not a bad thing, right? So it's good. It's a good skill to have. Okay. Do you guys see a pattern here? Purav, do you see a pattern here? I've written 3 triplets. Can you comment on what you observed so far?
Yeah. So in the first column, it increases by 2 every time.
It's an odd number, right? So the next, if I have to write a next sequence, it will start with 9.
The
Correct?
middle number is always in the ones you've listed down. The middle number is always a even number.
Correct. Anything else you're able to see? Middle is always even. The first is a set of odd numbers.
And then in the second one, it increases by 8, then 12. So in the second and third column, both of them increase by 8, then and 12.
Both of them are consecutive numbers, first of all, right? So 4 and 5 are consecutive. What happened here? Okay. 4 and 5 are consecutive. 12 and 13 are consecutive. 24 and 25 are consecutive.
Should
Right.
it be 4 into 12, the second one?
Sorry, for which one?
4 into 12, the second, like 4, 12, 24, and 4 into 12.
I didn't understand. So are you completing this one?
Yes.
Okay. What is it? Is it you're saying 48? Is it?
Yes, sir.
Okay. And then this is 49.
Yes, sir.
You can
Okay.
also have 9, 40, and 41.
Okay. Just one second. I'll be with you in just a second, Arjun. Okay. What is the logic, Arsh, for 9, 48, and 49?
So 9, we got that odd numbers like +2, +2, +2.
Yeah.
For
Correct.
the second one, I got first we did 4 into 3, then we did
Yeah.
4 into 6. So then we should do 4 into 12 because 4 into 2, like 4 into 3, then 3 ka double. So then 3 into 3.
I see. So is it 4 into 3 and 4 into 6? Therefore, you went for
12 because we're doing double.
3, 6, and then, but then this is getting double. 12 and 24 is getting double. 24 and 48 is getting double, but 4 and 12 is not double, no?
Oh, because no,
Then,
I'm not going for double. I'm going like we're doing 4 into 3, then we're doing 4 into 6, so then we should do 4 into
4 into 9 probably,
yeah,
or 36. Okay, that's one pattern in which you can observe. Yes.
I did
So-
4 into 3, I did 4 into 6, and then I did 4 into 12. So like 3 into 2, then 6 into 2, like double.
Okay.
So
All right.
multiple.
Maybe there were not enough terms to see a pattern. Okay. But yeah, that will not work. But Arjun, you called out the right thing. 9, 40, and 41 will work out. Okay, so Arjun, I don't want to take the surprise for others. So you figured out some pattern. I'll write one more and then you guys can see whether you can see a pattern from here. So this will be the next. Can someone complete the next one? Okay, I've given you now sufficient numbers to form a pattern. The problem, it's my fault, not Arsh's. I've given only 3 or 4. So anyone can make a pattern on his own, right? So now that I have sufficient number of rows, the pattern becomes very distinct. Okay. Akrit, I'll pass it to you. Do you see a pattern?
Sir, no.
Okay. Akshar, go ahead. Yes.
So the pattern is 4 plus 8, 12. So it's basically the table of 4 increasing. So it's 8, 12, 16, 20. So now it will be 24. So 60 plus 24 is 84. So it's 13, 84, 85.
Excellent. 13, 84, 85 will be a triplet. Okay. Precious, you said something?
Yes, sir, I did it differently.
Okay, go ahead, Precious. What did you do?
Yes, sir. So what I noticed was that the second one was 4 into 3. Then I noticed like the 7 one was 4 into 6. The 9 one was 4 into 10. And then the 11 one was 4 into 15. So essentially what we're doing is, so the 5 one is just 3. So then we are just like adding a number. So it's like consecutive numbers in the middle of them. Kind of like that.
I didn't understand. Please explain again. So you said 4 into 3. You're focusing on the middle column, right? So you said 4 into 3. Okay, 4 into 3.
3 is the important number. Then 4 into 6.
Okay,
6
4
is
into
an important number.
Okay.
4 into 10. 10 is an important number. And now 4 into 15.
Okay.
The pattern, this is the difference between 3 and 6 is 3. The difference between 6 and 10 is 4. And
Between 10 and 15 is 5. And then 15 and the next one should be 21. And therefore 4 into 21, which is 84. Yes.
84. Exactly.
Very good. That's also another good pattern to observe. Yes, Arsh.
I got that like 12 minus 4 is equal to 8, so 4 into 2. Then 24 minus 12 is equal to 12, so 4 into 3. Then 40 minus 24 is equal to 16, which is 4 into 4 and that.
Okay. Yes. You're seeing differences. So multiple ways, right? So you're seeing this difference is 8, this difference is 12, this difference is 16. Same. Okay. But the problem is, suppose I skip a lot of numbers and then down below somewhere, there's going to be a big number, let's say 51, right? Then based on what all of you told, I'll have to fill all these intermediate numbers. Only then I can arrive at this, correct? Which becomes a problem. Can you guys see a pattern within each row itself? Is there a way I can connect 9, 40 and 41 itself without looking at its predecessors or successors? That way, if I have to go to the row which is the first number is 51, I don't have to necessarily fill all these empty spots in between. Right? Yes, go ahead, Arjun.
Sir, the second and the third number, when they add up, it's the square of the first.
Excellent. Yes, very good. Okay, and we'll see why that works, right? So all of you, very good. I saw multiple patterns. Sorry?
Sir, the pattern different. Because this is like the 4th row, 9, 40, 41.
Correct.
Since it is the 4th row, then so like if we do 9 into 4 itself, then we get 36. 36 plus 4 itself is 40.
Correct.
And then consecutive. Then 7, it's in row 3. So like 7 into 3 is 21. 21 plus 3 is 24. 24 goes to 25. So that's another pattern.
Yes. So basically you're saying depending on which row it is, you multiply by some number and then add the same number. So 5 into 2 plus 2, right? 9 into 4 plus 4. 11 into 5 plus 5 and so on.
Correct.
Again, a small shortcoming there too is if I have 51, I should multiply by what and add what? Right? Yes, that you can figure that out also very easily. But yes, we'll come to that. Okay, in fact, let me just describe what he said. So basically he's doing 5 into 2 plus 2, which is 12. I'm sorry, I'm scribbling a lot here. As long as you're able to follow along, it's fine. 7 into 3 plus 3.
So it keeps adding by 1.
9 into 4 plus 4. Exactly. It keeps adding by 1. I still have to figure out which row number 51 corresponds to. Thoda bahut kaam hai. It's not like impossible. I can quickly figure it out, but maybe it'll take me 30 seconds to do that. But what Arjun described, my row is completely independent. Okay, his observation was when I add these two, I get 3 cos square. When I add 12 and 13, I get 5 cos square. When I add 24 and 25, I get 49, which is 9 square. 40 plus 41, 81 is 9. Sorry, 24 plus 25 is 49, which is 7 square. Slip of tongue. 40 plus 41 is 9 square, and so on. 84 plus 85 is 169. And therefore, his observation was the second and third numbers are consecutive numbers which add up to the square of the first number. Okay. So 51 square, how would we do 51 square easily without calculator? We just do 50 plus 1 whole square. A plus B whole square is A square plus 2AB.
square.
No, it is
Oh,
not A
this
plus
is
B square,
like
right?
Pascal's triangle, like A square plus 2AB
Plus
plus B square. Yeah.
So it's 2,500 is this, and then plus
That's
an 100,
2601.
2,601, right? So we need to arrive at two numbers. Arena, can you tell me two numbers, two consecutive numbers which add up to 2,601?
Sir, 1300 and 1300.
Please, whoever I ask, respond, please. I want to give everyone chance. Arena. Okay, so two consecutive numbers that add up to 2,601. How do you go about figuring it out? You're on mute. You're on mute.
Yes, sir. So,
You
sir,
know, Arena. I'm talking to Arena. Whoever I ask, please, guys. I don't want you guys to answer out of turn. Sometimes I'll say anyone can answer. That time, anyone can jump in. But otherwise, specifically, whoever I'm asking. Arena, you need to unmute and say something. Whatever you have to say.
I'm really sorry. I'm not understanding this, but I was just gonna ask you.
Oh, okay. No problem. Okay, did you understand the pattern that we last talked about?
The square.
Yes. So let's go through that, right? So when I square 3, I get 9, correct? So these two add up. These two are two consecutive numbers that add up to 9 in the 3, 4, 5. So let's take another example. Let's say the 9, 40, and 41, right? 9 square is 81. These two are two consecutive numbers. 40 and 41 are two consecutive numbers adding up to 81, right? Are you with me, Arena? Okay. Now with that pattern, I wanted you to tell what these two numbers would be. For 51, what should the other two numbers be in the triplet? So the first order of business was finding out 51 square, which we did using A plus B whole square. And we arrived at 2,601. You're with me so far? Okay. Now you tell me what should these two consecutive numbers be, which add up to 2,601. That's where we stand right now. You need to unmute to speak.
I'm thinking. One second.
You're making it more difficult than it actually is. How do you split 2,601 into two equal halves? You divide by 2, right? It'll be 1,300.5.
Yeah, yes,
Correct?
sir. So, and then you round it off. You round it
You
off.
get 1300 and 1301.
Exactly, right?
Yes,
You
sir.
literally divide by 2, and then aage piche you just
Then
insert
you
130,
just do
subtract half and add half. So 1300 and 1301, right? Can you guys take out your
understood it.
right? Take out your calculator if you have, all of you guys. Just try. Plus 51 square plus 1300 square and take the square root of that. That should work out to be 1301. Can you guys try it on your calculator? If you have one handy, you don't have to go searching. If you happen to have one, just, by the way, on the AMCs, there's no calculator allowed, which is why I'll emphasize a lot on mental math. But just as a verification process, I want you guys to try it if you have one handy. Does anyone have?
Right, so we aren't allowed calculators.
No calculators allowed for AMCs. Okay, which is why the problems will be very interesting, right? They'll seem like very big numbers, but if you know how to solve, you can really get to the crux of it without calculator. Arena is nodding. So you agree that it did add up to 1301 square. Okay, cool. Let's see why this is happening. Arjun, good spot on this one. Do you know why this is happening, Arjun?
So what is happening?
When you square this number and take two consecutive numbers which add up to that, that entire thing becomes a triplet. Do you know the reason for that?
So yes, sir, because sir, a square minus b square is equal to a plus b into a minus.
Correct. Excellent. Correct. So let me just expand on that one. Okay. So basically what he's saying.
Yes, sir, I did it. I got 1301 only.
1301. Okay, good. Okay. So let's generalize this. I'll start with some odd number. Okay. So we are saying we'll start with some odd number, right? Any even number can be represented as 2 times m. Correct? So if m is an integer, okay, if m is an integer, 2 times m would be an even integer. That all of us know. And how do we represent a general odd number? We represent it by 2m plus 1 or 2m minus 1. So 2m becomes even. Therefore, when you add 1 or subtract 1, it becomes an odd number. Generally, you will see 2m plus 1. That's a standard way of denoting an odd number. Of course, the premise is m is an integer. So on that note, when you assign variables also, choose variables carefully. Meaning, letters like K, L, M, they are all used for integers, right? It's not like that's set in stone, but generally use letters like X, Y, and Z for real numbers. By real numbers, I mean, it does not have to be integers. It could be 2.68, right? But if you know a particular problem where you're expecting a certain variable to be an integer, like, then definitely use variables like K, L, M. If you get into the habit of it, it'll save you some thinking process. It'll become a natural thing. So letters like K, L, M are integers, X, Y, Z, those are for real numbers. Okay. Now, an odd number is 2m plus 1. So what am I saying here? I'm starting off a triplet using an odd number. So I'll continue here. So 2m plus 1 is the first value in the triplet. Now, what is the pattern that we have guessed? We have guessed that let's first square 2m plus 1. Okay, let's square 2m plus 1. So that's a plus b whole square, right? Which is a square, which is 2m whole square, plus 2ab, which is 2 into 2m, plus b square. Okay, are you with me so far? Okay, now this is, think of 51 square. So for example, this is your 51 square. And this is the number which you arrived at. What was that? 2601 something, right? 2601, right? What is the next step that you did? You divided by 2, and then you did aage piche half and half so that you get 2 consecutive numbers, correct? So let's do the same thing here. We'll divide 4m square plus 4m plus 1 by 2, meaning it'll become 2m square plus 2m plus 0.5. And therefore, we'll subtract 0.5 and add 0.5. So we'll say this will be the triplet. Let me just take it up here. So I'm saying 2m square plus 2m is the one which is half less than this quantity divided by 2. And then half more than that quantity will become 2m square plus 2m plus 1. So I've not proved anything yet. I'm just writing based on the pattern we observed. We are guessing that this is what is happening. But we'll verify right now that it's indeed true. But are you with me? So Arsh, are you with me completely so far?
No, sir, not in this part.
Okay. So what did we do? We observed a pattern on a specific row. Forget about row to row, multiply by 2 plus 2, all that. In a specific row, we observed a pattern saying, if I square that odd number, again, think of an example like 51. 51 square was 2601. Then the next step was divide it into almost 2 equal halves. As in divide by 2, we'll get a non-integer. Aage piche, half and half. So 1300 and 1301. That's what we did in the numerical example. That's exactly what I'm doing with variables now. So I started with 2m plus 1. I squared it. I got 4m square plus 4m plus 1. That all of us agree, right? A plus b whole square. And then divided into 2 almost equal halves, which are consecutive numbers. So 2m square plus 2m, 2m square plus 2m plus 1. Now, my proposal is that these 3 form a triplet. Not proposal. My guess is that it's these 3 are triplet. Now we have to actually verify. That's a pattern we have observed. Let's verify that it's indeed true. That's where we stand. All of you with me? Akshar, you with me? Purav, you with me?
Yes, sir.
Okay. Now to verify, okay, so what do we have to verify? Let's say this quantity is, let's call this quantity as, I don't know, P or something. And let's say this is Q and this is R. We have to verify. I'll just say we have to verify if P square plus Q square equal to R square. Are you guys with me? That's what we have to verify. Or in other words, we have to verify if P square equal to R square minus Q square. That's what we have. If you verify, then we are we are confident that this is a triplet. Are you with me? Akriti, you with me? Okay, now let's verify and see. I wrote R and Q because it was too much to write these big numbers. So now it's time to write. So let's say 2m square plus 2m plus 1 square is the biggest quantity ka square minus 2m square plus 2m uska square. Correct? Let's see what, when we simplify this, what we get. Okay, so this looks like someone is saying, right, x square minus y square, which is x plus y times x minus y. All of you comfortable with all these basics, right? X square minus y square is x plus y into x minus y. All of you? Arjuna, you're okay with that? X square
Yeah.
minus y square? Okay.
So just repeat once. So just repeat.
Okay. Till here, are you okay? Prashant?
Yes, so till here I understood.
Till here, okay. Now this quantity looks like x square minus y square. So what is x square minus y square? X plus y times x minus y.
So just repeat once slower.
X
sir.
square minus y square is x plus y times x minus y.
Correct.
Agree? Correct? I'll apply that here. So this looks like x square minus y square. So I will say this is x plus y, which is 2m square plus 2m plus 1 plus 2m square plus 2m. That's my x plus y times x minus y would be 2m square plus 2m will get cancelled, leaving just 1. Are you guys with me?
So I don't get how you got the 1 on the other side.
Because it is x minus y. X is 2m square plus 2m plus 1. Y is just 2m square plus 2m. The difference is just the number 1.
Acha, हाँ, तो 1 ही बचेगा on that side.
Correct?
Can I
X
ask
plus,
a question?
right? And what is this quantity? This is the two consecutive numbers that we added in the first place. So this is that 4m square plus 4m plus 1, which is exactly the 2m plus 1, the whole square. So we are back to square 1. We did verify that the difference in these two squares actually gives iska square. I'll repeat it again. For those who understood, that's great. For those who did not understand, I'll go over one more time, right? We observed a pattern. The pattern was we start with any odd number, we square the odd number, we split it into almost 2 equal halves, as in 2 consecutive numbers which add up to that square. And we are proposing that is a triplet. The odd number ka square, when you divide into 2, the smaller portion and the bigger portion, 2 consecutive numbers. Those 3 form a triplet karke. That's our proposal. Yes, Araina, you had a question.
I don't understand where the raised to outside the brackets came.
Okay, so if I'm saying that these 3 quantities are forming a triplet, then I'll have to verify that when I square 2m square plus 2m plus 1, and when I square 2m square plus 2m, when I subtract those 2, I should get back the 2m plus 1 whole square. No, basic Pythagoras theorem. I'm verifying it now. Does it make
Sir, I
sense?
have a
Arina?
question.
Yes, Anjana.
Why did we start with p square plus q square equals r square?
No, we have to verify. That's what we have to verify. In fact, let's get rid of P, Q, and R. It's probably confusing, right? I'll just stick with these 3 numbers. Now, if someone says, okay, I'm telling you that these 3 are triplet or a Pythagorean triplet, what would you do to verify? Wouldn't you? And I'm saying this is in ascending order. I'll say this is the smallest, uske baad this, and uske baad this. What would you do to verify? You will verify that if this square plus this square is indeed working out to this square, correct? Right, Anjana?
Taking it as like a Pythagoras, yeah.
Correct. I am telling you it's a triplet, but you don't trust me. What will you do to verify? You will actually square the smallest one, add the square of the middle one, and check if it gives the square of the largest one. Correct?
Understood, sir. In a way, I kind of forgot about the triangle part of it.
Okay. Makes sense, all of you? Okay, so I said one way to verify is, which is why I introduced numbers P, Q, and R, right? One way to verify is you check, okay, check or verify. If P square plus Q square equal to R square. If it is right, then you're happy with my proposal. If you're not, then you'll say, no, you lied. That's not true, right? Another way to check is you'll do R square minus Q square, if that is easier, and you'll check if it's indeed P square. Both are same thing, right? So the latter turns out to be easier in this case to verify. Squaring this quantity, this big quantity, and squaring this quantity, and doing the subtraction of both, which is what I'm doing here. Arena, does it make sense to you now? right? And while doing the difference of the two squares, we leveraged x square minus y square is x plus y times x minus y, which is where Prashast was asking, where did I get the 1? The 1 came from x minus y. Are you with me, Prashast? No, completely.
Yes, sir.
Okay, so what is the long story? So in other words, I can generate a lot of Pythagorean triplets using this pattern. I can start with any number, for example. I can now go with, I'm not going to do this fully, but I can start with any odd number 73 and follow the same process. Whatever 73 square is, okay, fine. Let's not do 73. I'll pick a number which is ending in 5. Because ending in 5 is square is easy, right? What is 75 square? Arjun, what is 75 square?
There's 7 squares. No.
Does any of you know how to square a number which ends in 5?
Yeah.
Yep. Yeah, Purav.
To find the square of any number which ends in 5, so first you do 5 square, 25, so you get your tens digit and your ones digit, and then you multiply your tens digit of then you multiply the other digits of your first number to the next one, so 7
Exactly.
into 8, yeah.
Yeah, so he's putting a 25 at the end, and then he's multiplying 7 by the next number. So 7 into 8 is 56. So this becomes 75 square. So 75 square is this. Okay, does it make sense?
So can you repeat this?
Yes, sir. Wait. So sir, I just had a question about this only. So like, why can't we just do, like, why can't we break it? If we have to find 75 square, why can't we do 70 square, which is easy? 70 square is 490.
4,900.
4,900, correct, sorry. And then 5 squared is 25.
Mm.
And then now we have to find 2AB, which is 2 into 70. So that's 140. And into 5.
I agree with you. What is your estimate? In doing all of this, how many seconds will it take, Prashast? What is your estimate?
It would take a bit of time. It would take
How much time? How much time? Tell me. 30 seconds?
60 seconds. 60 seconds. Like,
Let's even half it. Let's say it's 30 seconds.
okay.
Okay. Now, if I tell you, I can tell you this in 3 seconds. Wouldn't you want to take it?
Yes.
So, and the method he's saying is, who was that? Purab said is, let's take another example. A few others probably did not understand the pattern. I'll explain again. So let's take some other number. Let's say 65 square. So all he's saying is, put a 25. The number ends in 5. Uska square ke liye, just put a 25 at the end. And then take this number before 5, which is 6. Multiply by the next number, 4225. Matter khatam. And it took me 10 seconds to explain.
Like
Next number to 6. 6 ka next number kya hai? 7. All of you
correct.
understand Hindi, right? By the way,
Huh?
anyone does not understand Hindi? Okay.
Yes,
All right.
sir.
My Hindi is broken Hindi, but sometimes beach mein Hindi mein ghus jata hu main. Okay. So 6 times 7 is 42. That's it. Right? Okay. Again, if I have 105 square, Akrit, what will 105 square be?
11025.
Exactly. Put a 25 at the end. 5 ke pehle jo bhi number hai, it could be a single digit so far. Now we are entering double digit. So what? 10 times the next number is 11. 11025. Matter khatam. That becomes the square of 105, the whole
Okay,
square.
but so why does this work? I mean, like, why should we use this?
Okay. Why should you use this is clear. Because
Yeah.
we can finish
But
it in
why
2
does it-
seconds as opposed to 30 seconds. Why does it work? I'm going to explain in just a second. Okay. So this is like a can of worms, right? As you open one thing, you'll get another thing. You'll get another thing. You'll get another thing. Okay. So let's, okay, let me just finish this thread and then I'll come back to why this works. So back to 75 square. So what was I saying? So I was saying if the 75 square is 5625, so 5625 divided by 2 would be approximately 2812.5. So 2812 and 2813. That will be a triplet. Okay, that's where we finished. So Arena, you understand why this is 2812 and 2813 now. Okay, so bottom line, I can form infinite set of triplets. I can keep going. I start with any odd number. Okay, you all understand the process now. I don't have to repeat it again. Now, बीच में किसी और ने दूसरा एक triplet सुनाया, which is interesting. 8, 15, and 17. That is not even in this league. You're not even starting with an odd number. You're starting with 8. Of course, you can say that even in 6, 8, 10, I'm not starting with an odd number. But after simplifying, essentially if I divide by 2, the common number, then it's 3, 4, 5. So that's ultimately the same pattern that we just saw. Start with an odd number, uska square karo, 9. Almost 2 equal halves karo, 4 and 5 mil gaya, right? So effectively this is same as this. That's like almost cheating, right? But 8, 15, 17 aisa nahi hai. It's a triplet which is outside of this league, right? 8 square is 64, 15 square is 225. Add up both, you get 289, which is indeed 17 square. All of you guys should know perfect squares till 1000. I don't mean squares of numbers till 1000. I mean perfect squares till 1000, meaning 31 square is the last square which is less than 1000. इसका मतलब ये नहीं कि उसके बाद सीखना नहीं है. If you can remember more, that's great. 32 square is a very famous 1024. If you do binary calculations, you might have seen this in computer science or any programming. 1024 is also a common number. Bare minimum, you should know all the perfect squares till 1000. The reason is, no one will ask you what is 23 square, right? Anyone can do it immediately and figure out what that number is, right? What is that number, by the way, Arsh? What is 23 square? I'm picking on Bichara Arsh. Okay. Okay, good. This is what I don't want. All of you guys should know perfect squares till 1000. 529, correct? The reason why you should know is, like again I said, it'll take 10 seconds for us to figure out what 23 square is. But if a question involved a number like 529 and some other extra details, if he knew that 529 is 23 square, maybe he'll figure out some way around it. But if 529 is just in any other number like 683 or 572 or something, he won't have a clue. But recognizing that 529 is 23 square, working backwards and recognizing it's 23 square will give you a big hint of how to solve the problem. Similarly, Arjun, what does the number 343 mean to you? Does it mean anything?
The 343 is 7 cube.
Excellent. Perfect cube. Perfect cubes till 1000 are also important. Okay. All right. What does the number? I'm going to call out the person and then call the number. To Purav Desai, what does the number 243 mean?
243 is 3 raised to the power of 4.
Very good. Almost close. 3
Or-
raised to power 5. 3 raised to 5. Not 4. 3 raised to 4 is 81. But very impressive that you recognize it's the power of 3. Powers of 2, powers of 3, perfect squares, perfect cubes, all of them till 1000 you should know. Right? Okay. One other. Anjana, what is 841?
Sorry, sir. 841.
Does it ring a bell?
841 should be a root of 9.
What is it? Say that again.
Be a root of 9 or 7. I'm not exactly sure what.
Okay. Okay.
Cube.
You mean you mean a power of 9 or 7? That's what you mean?
Yeah, a power of not a power of 9 or 7, but the root numbers will be 9 or 7, I believe. Because but I'm
you mean it must end in a 9 or a 7? Is that what you mean?
yeah.
It must end in a 9, fine, because 9 into 9 ends in 1. But why 7? 9
Sir,
or 1?
I know 1. There's a cube root of 7. Does that end in 1?
Cube root of 7? Say that again.
I'm not exactly sure though.
Okay, that's fine. No problem. Akshar, does 841 mean anything to you?
No, sir. I can't figure it out.
Prashast? No. Arjun?
The 841 is 29.
29
Sir,
square.
I can't hear you.
Okay.
Sir, I can't hear you.
Good. So I feel good for Arsh now because he's not the only one, right? So all of you are struggling with perfect squares till 1000. I mean, I'm not blaming you. No fault of yours. But all of this competitive math ke liye, you should be on top of your perfect squares and perfect cubes, right? I liked Arjun's speed here.
Like memorize
841
this.
turant pehchanna chahiye ki it's 29 square. Yes. Sorry. Prashast, you had said something?
So should we like memorize this or is there like
Memorize this. Memorize this as a ratta mark nahi hai. You should get a feel for the numbers over time. Yes. Pehle just ratta marna padega, but over time it'll automatically become, you'll just remember it over time, right? And ratta marna buri baat nahi hai. So it's not a wrong thing to by heart. So it's cool to not by heart. No, that's I don't believe that, right? Few things have to be memorized and there's no harm in it. And it's not like ratta is a bad tag or something, right? It's a skill to be able to retain something and memorize and retain something. It's a skill, I would say, right? And what I'm against is just by heart something without understanding any meaning. That's a different thing. And वो भी करना पड़ता है. Social studies, for example, I used to be horrible in it. I had to just digest all of it and just spill it all, right? So that is bad. But here we are actually internalizing some of these numbers, right? Which is perfectly fine. Yeah. Anyway, I've made the point by giving a few examples. One more example. Let's say we didn't put Arena in the spot. Arena, you want an easy one or a difficult one?
Easy, please.
No, you should ask a difficult one, because even if you don't get, it's not a big thing, right? It's a difficult one. If it's easy one, agar fasogi, to bahut buri lagega na. Okay, so 729 Arena. Okay, passing to Akshar.
So 729. So can you give me like 10 seconds, sir?
Nahi. Instantaneous answer. Already you consumed 10 seconds, which was given to her, right? Akrit,
9 cube.
9 cube. Anything else?
2 to the power of wait, sir, 1 second. No, I mean 27. Wait, 27 squared.
Anything else?
3 raised power 6.
Exactly, 3 raised to 6, right? 729, a lot of things buried into this, right? And of course, what is 1729? Arjun, you don't have to answer, but you know or you don't know?
13 cube.
No,
Okay,
so
it is not,
I'm
okay.
thinking.
Whoever answered 13 cube, no, because 13 cube will end in a 7, right? 3 into 3 into 3 will end in a 7. It cannot end in a 9. Okay, 1729 is neither a square nor a cube, but
That's
it's a very,
12 cube plus 1.
exactly. It's 12 cube plus 1 cube. It's also 10 cube plus 9 cube. This is the famous Ramanujam number, right? So it's the smallest number that can be expressed as sum of 2 different cubes in 2 different ways. Okay, I'll repeat that statement. It's a very, very heavy statement, and he made it very casually, right? The great scientist, the great mathematician Ramanujam, right? Just casually, he was waiting for a car or something to pick him up, and then he and his friend, and then they informed, back in those days, like you don't have all the cell and all that, right? So they were informed of the car number. His friend, who was a good mathematician in his own right, by the way, standing beside him, and they informed the number was 1729. He took a pen to write out this number because they would have to expect that number, that car to arrive, right? But Ramanujan said, you don't have to write it down. For example, if the car number is 100, will we write it down? It's a very nice round number, right? It's right? So like that, so 1729 was also a very obvious number to Ramanujan. Why was it obvious to him? Because he said it's the smallest number, as if it's a very, very casual thing, that can be expressed as sum of 2 different cubes. It's 12 cube plus 1 cube in 2 different ways, as well as 10 cube plus 9 cube. Right? So 1729. 1728, someone said it's 12 cube. That's fantastic. So 12 cubed is 1728. So it's not like you cannot go beyond 1000, right? At least till 1000, you should know all of this. Knowing more is always better. Okay. Now, where were we? Right? So, so we were in 75. Okay. Now I have to prove to Prashast, because he won't leave me unless I do that a number ending in 5 uska square karoge, so why does it follow this pattern? So let's do this. Okay, so okay, this is a triplet, right? Okay, so what am I saying? Let's say I have a number ending in 5. So the way you write a number, okay, forget this. Suppose I write a number PQR. This stands for the product of the 3 numbers P, Q, and R. But if I put a bar on top of it, it means a 3-digit number formed by the digits P, Q, and R. Okay. So when we say 387, right, we don't do that because no one is going to misinterpret it to be 3 times 8 times 7. But when I am using variables, how do I differentiate between the product and a 3-digit number? So for that, if you put a does not have to be 3 digits, any number of digits, any number, to say that I'm talking about the digits and not the product, you put a bar on top of it. So for example, right now what we are talking about is 8A5, right? A number ending in 5, but to be read not as the product of A and 5, but the 2-digit number A5. And again, I'll start with it, but see that A does not have to be a 1-digit number. A can be itself a multi-digit number, like we saw 105, right? A was 10 in that case.
Yes, sir. Okay, so that I got.
Okay, all right. Okay, no, I'm just saying in general to you, not in general to the class, not just you. Okay, so A5, uska square, right? So what am I saying? In fact, okay, what am I saying? I'm saying this will end in 25, and then iske aage jo bhi daloge, that will be the number A times A plus 1. So this will be the number. You'll put A times A
Wait.
plus 1,
This is
and then
so where did A times A plus 1 come from?
that's what we said, right? I'm yet to prove it. But what did I say 75 square was? If you recall, I said 75 square karne ke liye, first you put 25 and then multiply 7 with the number after that, 7 into 8.
Yeah.
Right? So I'm saying this is the number, right? 7 into 8 followed by 25. Now in
Correct.
this case, A into A plus 1 followed by
565.
25.
Okay. Got
This
it.
is what I have to prove. I'm just saying this is what I'm going to get to, but I'm just writing it out just for clarity.
But this doesn't work in 15 square because you write 25 and then 1 into 2 is.
It's true, no? It does work. 15 square. So
Oh,
you end
yeah.
in 25 and 1 into 2 is indeed 2. It does
Okay.
work. Okay. All right. So why does it work? So what is the meaning of A times 5? So for example, back to this question, 75 ka matlab kya hai? How do we know this to be right? Just imagine you're a robo. How does the robo recognize that 75 is the 75 that we know? Because it knows that this is the tens place and this is the units place. So it'll interpret it as 7 times 10 plus 5. That's how we learned 2-digit numbers back in kindergarten or first grade, right? So we said this is tens place, this is units place. We said this is actually meaning 7 times 10 plus 5. Similarly, the number A5 actually means A is the tens place, which means it's the number 10 times A, and 5 is in the units place. So just plus 5. Yeah.
Correct.
Arena, you with me as well? Anjana, you're okay? Okay, good. Now, you guys can give just a wala thumbs up like Anjana just did, right? Prashant, you don't have to, I mean, I'm perfectly fine with you opening your mouth and just saying, but you don't have to force yourself to unmute and say that, right? Can give an electronic thumbs up or whatever, right? Okay, cool. So now 10a plus 5 ki square ki baat ho rahi hai abhi. So 10a plus 5 square. So what is x plus y whole square? X square plus 2x y plus y square. Okay.
Sir,
Yes.
I could quickly use the bathroom. I'm so sorry. It'll just take us.
Sure, no problem. But I'll march on. You can always come back and catch up, right? Okay. So this will be, or if you can just hold for 5 minutes because I'm almost done, right? We're almost near the end of the class. Okay. So 10a whole square will be 100a square.
Correct.
Okay. 2 times 5 times 10 would be 100 again, plus 100a.
Okay.
Plus 25. Okay.
Okay.
All of you with me so far? Prashant is answering on everyone's behalf.
What is
Yes.
the question you're trying to prove here?
I'm trying to prove that जो भी बताया था, when I do 75 square, why do I get this number 5625? Why is it that when I take 7 and multiply by the next number and lay it all out as a big number, why does that become 75 ka square? Uska proof मांग रहा था Prashant.
Sorry, sir, I'm confused. What did you say?
I was trying to prove why a number ending in 5, uska square, follows this pattern of ending in 25 and then preceding by the number multiplied by the number next to it. Right?
Because 7 into 8 is equal to 56 and then 5 into 5 is equal to 25. Yeah.
Yeah, correct. I'm proving it, right? I haven't proved it. That's what I'm trying to prove right now, right? With a general example, with a general notation A5. All of you with me? I don't know, beach mein why we are going back to the basics. I thought we covered it. I mean, I welcome doubts, but I also don't welcome doubts that are coming very late in the process, right? I thought this is what we said we are going to do. Uske baad, deep into the process, I'm getting the same question back again, right?
Yes, sir. Yeah.
No fault of anyone in particular. I'm just saying, in general, be attentive. And then if something is bothering you, block me right then and there and ask rather than go for later. Okay, all of you with me by now, assume, right? So this is what 100a square plus 100a, which is nothing but 100 times a square plus a plus 25.
Okay.
Okay. So this is nothing but 100 times. Okay, fine. So this is the number. So in a way, this is like 25 is in the last 2 digits. And in this hundredths place, I have the number a square plus a. So just think of it as a 3-digit number like this for now. So a square plus a is in the hundredths digit. 2 is in the tens digit. This is in the units digit. What will the value of that number be? It will be a square plus a times 100 plus 2 into 10 plus 5 into 1. Right? And that's exactly what we got, see. And a square plus a is nothing but a into a plus 1. So in other words, I'm saying in the hundreds place, put the number a into a plus 1, which is a square plus a. And then in the tens place, put a 2. In the units place, put a 5, which is actually what we said we were going to do. Does this make sense, guys? Arjun, does it make sense to you?
Yes, it does.
All of you? Akrit, Akshar, Purav?
Yes,
Yes,
sir.
sir.
Sir,
Yes.
understood.
Cool. Okay. So now we have about 3 minutes to finish. Anjana, if that's okay with you, let's finish it. Even otherwise, I'm not saying people cannot take breaks, nothing like that. Do announce and go and come back, but I'll keep marching on. Otherwise, we cannot wait for bathroom breaks for everyone. But of course, the entire session will be recorded and sent after class. In fact, there are at least 3 absentees today. The class is supposed to be of strength 10. I don't know who 3 are missing, but they are definitely missing. They'll be watching the entire class in recording. And I urge you guys also who attended the class to watch the recording, because when you go for a second pass, things sink in a lot better, right? So even if you attended class, play it at 2x speed or some fast speed, but go through it once, please. Okay, so where were we? The last part to complete is 8, 15, 17, beach mein kood gaya, which is not even in the triplet that we saw. So the triplet family that we saw was only one of the many other triplets that are possible. Now this is a new one. Okay, so where am I getting this one from? Now, I'm saying, okay, I'm saying if I have 3 numbers, if I pick any 2 numbers, A and B, okay, let's say A is greater than B, and I generate 3 numbers out of it. What 3 numbers? A square minus B square करके एक number, 2AB करके एक दूसरा number, and A square plus B square करके एक तीसरा number. I'm saying these 3 form a triplet. Okay, so square का square होगा अभी, right? I'm saying these 3 are triplets. First, let's verify, and then we'll take an example, right? So in fact, maybe we'll just take A equal to 4 and B equal to 1. Okay, and we'll see, right? When you do this, A square minus B square will be 16 minus 1, which is 15. 2 into 4 into 1 will become 8. 4 square plus 1 square will be 17. In this pattern, you're not guaranteed that the smallest number will be the leftmost. The smallest can either be A square minus B square or be 2AB, but the biggest will always be A square plus B square. Okay, but in this example, this 8, 15, 17 generate karne ke liye, I picked A as 4 and B equal to 1, I got 1. But first, let's verify. Does it make sense? A square minus B square, usko square karte hain pehle, right? Because I have to verify, right? How do I verify? I'll verify whether this chotu ka square and this medium, whatever, we don't know in which sequence they'll come. Let's say the first 2 ka square and add them and see what I get. Ideally, I should get the third one ka square, right? Let's verify. So when I do this, I get A power 4 minus 2A square B square plus B power 4. Agreed? When I square this, because this looks like x minus y whole square. X square is nothing but A square whole square, which is A power 4 minus 2AB plus B square. Akshar, you with me?
Yes, sir.
Okay. Plus 2AB ka whole square is 4A square B square. So when I add this, what do I get? I get A power 4, ऐसे ही रहेगा, B power 4 भी ऐसे ही रहेगा, minus 2 and plus 4 become plus 2. So this becomes plus 2A square B square. And this is nothing but A square plus B square, the whole square, which is exactly what we wanted to make it a triplet. Does it make sense? Right?
Yes.
Yes, sir.
Yeah. So now let's try some other numbers. Prashant, give me 2 numbers A and B where A greater than B. 2 small numbers. Don't give big numbers.
Okay, A can be 17, B can be 20.
छोटा number बताओ यार. 10 से नीचे.
Oh, 10 se niche. So then like
So that we can easily work it out.
A can be 5, B can be 7.
B, A is greater than B.
A is, oh ha, so then 7 and 5 ulta kar le.
7 and 5. Okay. So 7 and 5 ulta kar lete hain. So 7 and 5. Okay. So then what is my A square minus B square? 49 minus 25. That's A square minus B square, which is 24. 2 times 7 times 5 is 70. Okay. Okay. And then 49 plus 25 is 74.
74.
Correct. So 24 square plus 70 square ideally should be 74 square. इसको थोड़ा कम कर सकते हैं ना? 12, you can verify this, or you can verify 12 square plus 35 square is 37 square. Either way, you can verify this. Okay, can we verify
Yes.
this quickly? Yeah, actually, let's do the original one only. So how do I verify this? One way to verify this would be not square 24 square and add 70 square. Instead, we'll verify 74 square minus 70 square. That's easy to verify because it's 74 minus 70 times 74 plus 70. There's a reason why we read x square minus y square and all to apply in cases like this. So this becomes 4 times 144. And kiska square hoga? That'll become 2 and 12 ka square, no? Because this is 2 square times 12 square. So this is, which is exactly 24 square. So we verified that 74 square minus 70 square is indeed 24 square. Therefore, we know this triplet, right? And this is definitely not coming from a number that's generated starting with an odd number, right? But starting with an odd number, that will also work. For example, the 3, 4, 5, or let's say 5, 12, 13. 5, 12, 13, kahan se mila, for example. We can say A is 3 and B is 2, maybe. Then A square minus B square will become 9 minus 4, which is 5. 2AB will become 12, 2 into 3 into 2. A square plus B square will be 13. So this method will also give what we already studied, starting with an odd number, O wala. Plus it will give a few more like this 8, 15, 17. And what did we just saw? What did we just see? 24, 70, 74. Or in a simplified form, this is 12. If I divide throughout by 2 and simplify, this 12, 35, 37 is another triplet that we just saw. So these are extra in addition to the first set of triplets that we studied, right? Okay, it's a good point to stop here. We'll stop here. I'll share the recording after class, sometime later, right? Okay, chalo, bye.
Bye, sir.